Okay, students, so let's start with the last part of important questions for the chapter sets for class 10. The question is, if u is equals to 1 till 7, a is equals to 1, 3, 5, 7, b is equals to 3, 4, 5, 6, then prove that A complement union B complement is equals to A intersection B whole complement. Now, as we were doing it earlier, we are going to take the left hand side and the right hand side separately. Let's start solving. Taking the left hand side first, A complement union B complement. We are going to find out A complement and B complement separately first and then take the union of both. And as we know that A complement is equals to U minus A, that is the universal set minus A. So A complement will be equal to, writing down the universal set first, minus 1, 3, 5, 7, that is set A. Now cancel all the elements that are in A from the set U to get your answer, that is remaining elements from set U. A complement is 2, 4, 6. Now let's calculate B complement U minus B. B complement is equals to 1 till 7 minus 3, 4, 5, 6. Over here also we are going to cancel out 3, 4, 5, 6, which are the elements of set B. And the leftover elements will be our answer 1 to 7. Now we are going to take the union of both these answers, A complement and B complement, and when we take the union, you know that we are going to write down all the elements of both the sets combined in one set without repeating them and also writing them in order. So our answer is 1, 2, 4, 6, 7. Now let's take the right hand side. A intersection B whole complement is equals to U minus A intersection B. Now over here also we are going to find out A intersection B first. A intersection B is equals to 1, 3, 5, 7 intersection 3, 4, 5, 6. Now again, when we are taking intersection, we are just going to write down the common elements and leave the others. So the answer is 3, 5. Now we are going to take its complement, that is subtracted from the universal set U, and you will get the answer 1, 2, 4, 6, 7. Now as you can see that the right hand side is equal to 1, 2, 4, 6, 7, which is also equal to the left hand side 1, 2, 4, 6, 7, and hence our answer is proved. Now let's move on to the next question. If A is equals to 1, 2, 3, 4, B is equals to 2, 4, 5, 6, C is equals to 2, 3, 6, 8, then find A minus B cross B minus C. Okay, so we have a new term, that is this cross. This symbol represents the Cartesian product in sets. Now let's understand what is the Cartesian product. The Cartesian product is basically finding out ordered pairs from both the sets, which will represent the 2 points on x and y axis on the graph. We'll find out the Cartesian product of these two sets, but first of all we are going to find out A minus B and B minus C, and the answer that we get, then we are going to find the Cartesian product. So let's find out A minus B first. We'll write down the elements of set A minus the elements of set B. Cancel out the common elements, but the answer will be only the leftover elements of the first set, that is 1 and 3. Now in the similar manner, we are going to find out B minus C. 2, 4, 5, 6 minus 2, 3, 6, 8. We'll cancel out the common elements and write down the leftover elements of the first set only, that is 4 and 5. Now when we want to calculate the Cartesian product of A minus B and B minus C, the answers we've got. First of all, let's make a diagram. A grid sort of. The elements of the first set we'll write down over here, 1 and 3. The elements of the second set we are going to write down over here, 4 and 5. Now, when we make ordered pairs, we take 1 from the first set and make an ordered pair with this first element of the second set. Again, take 1 from the first set and 5 from the second set. For the second ordered pairs of ordered pair, 3 from the first set, 4 from the second, 3 and 5. So this is the way we find out the Cartesian product of two sets. Now we will combine these and write them down in a single set. So this is how we have written our ordered pairs in a set form, that is known as Cartesian product. Now next question. If A is equals to ABC, then find the power set of A. Now let's understand first of all what a power set is. Power set is basically finding out all possible subsets in a set. All possible subsets. So over here we have this set as A, that is ABC are the elements. Now we are going to write down all the possible subsets that can be formed from this set, and we are going to write them down together. Now as you can see, we have the first possible subset as phi, which we can also call it as a null set, empty set, then only A in a set, then B, then C, then a pair of A and B, pair of A and C, a pair of B and C, and the whole set itself. So these are all the possible subsets that can be made of the set A. So this is known as a power set. Now let's see how we can calculate the number of elements or the number of subsets that a power set can hold. There is a simple formula, 2 to the power n, where n is the cardinality of A. Over here we have 3 elements in set A. So the cardinality of n or cardinality of set A will be 3. So we are giving power 3 to 2, and 2 to the power 3 will be equal to 2 into 2 into 2, that is 8. So we should have 8 subsets. Now let's count 1, 2, 3, 4, 5, 6, 7 and 8. So our answer is correct. We can also check our answers in this manner. Now next question. If A is equals to ABC, B is equals to XY, then find two binary relations in A cross B. Now over here, first of all, let's calculate or find out A cross B, and then we'll explain you what binary relations are. Making the same diagram for finding out A cross B, we'll write down the elements of set A first on this side and B on the other side. One thing to remember, A cross B is not equal to B cross A. So over here you must remember the first set will be written on this side in the vertical column. The second set is going to be written on the horizontal column, and the Cartesian product is also going to be different if the order is changed. So the elements of set A are A, B, C. Elements of B are X and Y. So let's make the ordered pairs. AX, AY, BX, BY, CX, CY. Now writing them all down together, you are going to get the Cartesian product of A cross B, and this is how we got it. Now, for binary relations, in mathematics, a binary relation over two sets is a set of ordered pairs consisting of elements, for example, let's say X in the first set and Y in the second set. In other words, it's the subset of basically the Cartesian products. So if you have to take out binary relations in any set and the Cartesian products, we are simply going to write down their subsets and represent relations with the letter R. So over here, the first binary relation that we have taken out is R1. That is A and X. If you want to take out another binary relation, we'll label it as R2, and then you can choose any ordered pair and make it a subset and write it down as a binary relation. If you want to make more ordered pairs, maybe you can write down R3 and write B, Y, CX, CY, R4, maybe just write down phi. That is also going to be a binary relation because phi or null set is always a subset of the main set that you are considering.